Alrighty, just checking to see if audio is working. It looks like it is. Let's go ahead and look at 9.9 now. Okay, 9.9 is about the area of circles and sectors. Okay, so a couple key things to remember here is that the circle has a particular way to find the area, just like any other shape and whatnot. So kind of just remember that part. Um, I don't actually have it on my PowerPoint here, but our do first for the day was looking at area. So our area for a circle A is going to equal I r squared. Okay, so make sure that you do have that on your paper. And something to kind of remind ourselves on that r, the radius, is half of the diameter. Okay, contrary to the last section 9.8, 9.8 allowed us to say, oh well, I can find circumference with pi or 2 pi r, or I can find it with pi times d. However, in this case, there is no option for diameter. It is solely on the radius. Okay, so looking at this kind of stuff, okay, we already know what a circle is, and we're introduced to this thing called a sector. Okay, a sector is just a part of something. Okay, so for instance, right, if we were to look at, um, let's see, let's imagine that our school, right, let's imagine our school was a big circle, right, and my classroom is in the C block. Okay, well, C block is a sector, a piece of the entire building, not the whole building, but a piece of the whole building. Okay, so kind of think about it like that. It's going to make things a little bit easier for you to kind of think about. And another way to think about it is if imagine you have a pizza, right? You have a circle for a pizza, and you wanted to just take one slice. That is a sector. Okay, that is a piece of a pizza. Okay, so whatever this area is one slice, whereas everything else here can be whatever it is. Okay, so thinking about it like that. Another way you can think about it would be like cake, pie, or anything else that's kind of circular in nature, like that. A cookie, actually, a cookie's another good one. Oddly enough, a lot of our dessert-esque foods are coming to mind. But any other kind of food is possible as well. Um, but I kind of want to bring back this topic right here, um, where we have this formula on our formula sheet, okay? And I want us to take a reference back to 9.8, where in 9.8, we basically said a piece of the circumference on top of the whole circumference equaled a piece of the arc over the entire arc. And that's essentially what's happening here as well, where we have a piece of area divided by the whole area equal to piece of arc over whole arc. Okay, so we've seen this idea numerous times throughout our time here in geometry. So this is not the first time we've seen this relationship here, where we have essentially a fraction, right? A fraction, let's just say a fraction of area, we'll call it, equal to a fraction. That's not what I want to do. Equals a fraction of. Okay, so this is not a foreign concept to us. This is very well known to us at this point. Okay, so it's not, it's not a hard concept, I don't think, but it could be a tricky one given that we have some different ways to solve it and whatnot. But we'll see some examples and we'll see how to solve those and figure them out. Okay, we'll go ahead and take some time looking at example 1. Okay, it says it wants to find the areas of these sectors, plural. Okay, so you want to make sure you're doing both sectors. Okay, so find the areas, the sectors formed by angle UTV. Okay, so in this case, we're going to identify which sector we want to do. Let's go ahead and identify this sector as our red. I'll do it in red pen. You can do it, of course, in whatever you have available to you. But if I'm trying to find the sector, right, I'm trying to find that piece, that fraction. Okay, so we're going to look at our equation. It's up here at the top. Area of the sector is what we're looking for. So we'll call it X. And let me just clarify, this is for our smaller sector. Okay, so just write that right there. And then the area of the sector is on top of the area of the circle, which we of course know as pi r squared, equal to the arc measure, which in this case is 70. And then of course we're going to have 260. Well, here we're given a radius, so we'll replace our radius. We'll have x over pi x8 squared equals 70 over 36. Okay, oh, not 36, 360. Okay, and I know a lot of us immediately want to just simplify our fractions, and you know what? That's not a terrible idea. Okay, however, what I think is going to be a little bit easier for us to do, because we have access to the calculator on our tests and our quizzes and whatnot, just put out the front of the work, like do all the math manipulation on paper, and then just plug in your answer into your calculator. So in order to get rid of this pi, 8 times 8 to 8 squared, I should say, in order to get rid of that, we're going to multiply both sides by that pi, 8 squared. Anything we do on one side, we have to do the other side. And so now we get the value of x to equal 70 over 360 times pi 8 squared. And you can simplify 8 squared to 64. Okay, that might be easier to write so that you're not confused. But you're just going to plug exactly what is written right here into your calculator, and you'll find yourself an answer. And that answer, of course, is going to be x equals 39. It was 39.695. Going careful here. Okay. Beforehand, we were talking about inches and centimeters, meters, miles, all that stuff. Here, because we're talking about area, we have to look at our units. In this case, we're working with inches. But because it's the area, it's going to be inches squared. Okay, so make sure you catch that. And now for our major arc here, right? This section right there. Okay, we're trying to figure that out. Well, we can go through the whole thing with finding the equation and putting into the proportion and all that stuff. We could do that. That'd be a smart thing to do. However, there's a even better way for us to do it, is that we're just going to find the arc, sorry, not the arc, we're going to just find the area of the circle and subtract our smaller arc from that circle, okay? It's just going to make things a lot easier for us. So for our larger arc, we're going to take A equals pi. We already know the R is 8 squared. And realistically, you could just say that this is going to be 64 pi. Okay. And because 64 pi is the area of the whole circle, you're going to take the area of the whole circle, 64 pi, and then just subtract 39.695. You'll find yourself an answer. When you do this, you should get an answer of 161.967. Of course, this is going to be in inches squared. Okay. Again, just really not that difficult, I don't think. We'll find some other problems that may be a little bit more difficult for us. But I don't think we should have a huge amount of issue with this, as long as you're like actually following along, copying the notes down and everything like that. we'll see how it goes. Go ahead and try the next problem before we move on. Try it on your own. And actually, like everything from here on is just work really. So kind of just go at your own pace as needed. But yeah, try this. And now that we're back, we'll go ahead. Let's go ahead and do our smaller arc again. I think doing the smaller arc just makes a little bit more sense. A little bit nicer of a number. Okay, we have this 135. Okay, 135 equals 360 degrees. That equals, right? We're looking for the area of the sector, so we got to keep that as an X. We look for the area of the circle. We need the radius. The radius is 15, so pi 15 squared, like so. And then we just solve for X. And again, this is going to be for our smaller sector number. Okay. Multiply across. X equals 135. Or not 1, but 360 times pi times 15 squared. And whenever you do all that, you should get a value. Let me make sure. Oops. You should get a value of 265,072. This is going to be in centimeters squared. Very nice. And again, we're going to keep taking the exact same approach that we did in the last problem. In order to find our larger angle. Sorry, not larger angle, larger sector. Okay, we'll just take the area. (15 squared) is 225. Give it pi. Get your 225 pi minus 265,075, sorry, 072, and you get your answer of 441.786 centimeters squared. Just like that. Pretty. Okay. All right. Looking at these problems, they're a little bit different. Okay. Here in this first one, we're given the area of the sector already. Okay, that's what this is right here. The area of the sector. So what our goal is to find the area of the circle now, okay, given a sector. So we'll work backwards a little bit. We have 35, where we normally, or not normally, but where in the previous problems we had next, we now have a 35. And we actually have an X here for our area of the circle. Notice that it does not give us the radius, so we cannot actually figure it out through that method. But here we can figure it out this way. We already know what the arc measure is. It's 40 degrees. And we have 360 degrees. Okay. We know that this is going to be 40 degrees because of that central angle relationship with this arc. So don't be alarmed as to why I'm just saying that this is 40 degrees. We already know, we already learned that a central angle is equal to its arc angle. Okay. It's only the inscribed angle and its intercepted arc that they are, their relationship's a little bit different. Okay. So from here, we're going to solve for X. The easiest way, cross multiply. So 40X equals 35 times 360. Okay, but there's a little bit of a trick here, right? Again, you don't want to put this into a calculator yet. Divide out the 40. Get X equals 35, 360. Go by 40. And when you do all of that, you're going to get a value of, not 3, X equals 315 meters squared. Yep. A lot of this is just using a formula, putting it into a calculator, or sorry, using a formula from the formula sheet, manipulating it mathematically correctly. Okay, cannot forget the correctly part. And then from there, plugging into a calculator and solving. Okay, a lot of this you can't really do on your own, just because I know your skill level, and it's just much more easy. It's much easier, I should say. It's much easier to do it this way with the calculator. Okay, go ahead and try extra example 2 first, and come on back. Change it. Let's do green this time. Okay. Similar problem. We already know that this is going to be our angle, sorry, not angle, our area of the sector. So we'll replace it 48 over x is what we're looking for. The area equals 135 over 360. Okay. So we have that. And we keep going. We're going to cross multiply these two, just like we did in the last problem. We get 48 times 360 equals 135x. Divide out the 135, divide out the 5. X is going to be equal to 48 times 360. Oh. Okay. So from here, we're going to go ahead and put that into our calculator. And the calculator results is going to be x equals 128. Okay. We have 2 more examples here. Now this example is a little bit trickier. Okay, now first off, we have a word problem that's already tricky enough. But now we're working with other shapes too. So a rectangular wall has an entrance cut into it. Okay, that's the fluff, right? That's the background. You want to paint the wall. Okay, we want to paint a wall. Okay, that's what we want to do. To the nearest square foot, so we want to be in feet. What is the area of the region that you need to paint? Okay, that's exactly what the question is asking. So we want to find the area of a region. Okay, and if we look at our diagram, it's not very clear on yours, on your papers, but if we look at our diagram, this is what we're looking at. This is what we're working with here. Everything in green right here is what we want. We don't want anything else. So there's a couple different ways we can do this. Okay, the first way, well, rather not the first way, but the first thing we have to do is we have to establish what is this whole area. Okay, the green is what we want. The red is what we don't want. Okay, everything in that red here is what we don't want. But in order for us to figure out what we don't want, we need to first establish what is blue. What is this rectangle here? Okay, so I'm going to do it in stages. Okay, we're going to find our whole wall. So, whole wall. Okay. The whole wall is just a rectangle. So the rectangle is going to be 36, because that is my length from the bottom. And then our width, or I guess technically our height, right, if you're thinking about this three-dimensionally, is going to be 26. We know it's going to be 26 because 10 and 16 add up into 26. Okay, so don't be alarmed there. Whenever we find 36 times 26, we get the value of 936. Okay, so that's the first part. But if we want to figure out what our green area is, we need to first take out the red. Okay, so this is going to be the opening or the entrance, whatever you like to call it. Opening. The opening is split into 2 shapes. One, we have a semicircle. And we have a square. And we know this is going to be a square because we have 16 right there. And we know that that height is also 16. Okay, so it's a square. And so doing so, we get our semicircle. We need to find our area here. It's very clear that this is supposed to be a diameter. Okay, so don't be alarmed there. This is very clear that it's supposed to be a diameter. And so we take this semicircle. We do our area of the semicircle, which is going to be pi times r squared. In this case, I'm given a diameter, so be careful. It's not going to be 16 squared. It's going to be 8 squared. Okay, so be careful. Plus, well, 16 times 16 is going to be 16 squared. And I plug this all into my calculator. So what I get out of that value is 356.531. Okay. So now finally I can figure out what my green value is. My green value, the whole, or not the whole, but the wall or paint, we'll call it, is going to be equal to the whole wall. Sorry, I'm going to try to color coordinate this as best as I can. Whole wall minus our opening. Go from there. We know our opening is 356.531. We also know that our whole wall is 936, and that there is some amounts of subtraction in between there. So we got to subtract there. And of course, this is what we're looking for our wall to paint. We're going to abbreviate it as WFP. Okay. And we just subtract it out. That's all we got to do. So the total area, A, is what we're actually looking for. So A equals 579.469 feet squared. Okay. Okay, so it's actually much easier than we may think. Okay, so don't get too discouraged on it. Now that we've done this problem, go ahead and do the next problem. A very similar-esque problem, but it's set up a little bit differently. Go ahead and try it. All right, so now that you've tried it, maybe you didn't, I don't know. I can't really monitor you on that, but I really hope you did try. We're gonna go ahead and find the area of the shaded region within the rectangle. Okay, so in this rectangle, right, we are looking for only the green. Okay, so I'm gonna kind of color coordinate that stuff again. So we want the green area. So all these little pieces here, everything here, as much as we can get. Okay, obviously this is a much more interesting problem than the last one. First thing we have to do, like we said in the last problem, is we have to figure out what the hole is. Okay, all the way up here, all the way, like so. Okay. But we don't want the red. Right here. We don't want this red here. Okay. Now, a little trick though is remember the radius. The radius is a segment from the middle, direct middle of the center of the circle, to the edge of the circle. And I say edge, but it really doesn't actually have an edge, but the center to the circle. So that means that any variation of the radius is going to be equal to each other. Okay. This is helpful. Okay, this is helpful because I know that if I go from my center, go directly to the right, that means that that is going to be the same radius as it was beforehand. And so the radius here is 6. That means that this value, right there, is going to be 6 feet. The same exact way that if I found it on the other side, this value right here, is going to be 6 feet as well. So in actuality, this side of the rectangle is going to be 12 feet. Okay. We'll take that same thought process and we'll go on the other side. We know that this value right here has got to be 6 feet. Same that this value right here has to be 6 feet. Same with here, the same value, and you see where I'm going with this, right? 6 feet, 6 feet. If you add all that up, That's going to be 24. Okay. Some of us probably already saw that immediately. Some of us didn't. That's okay. We'll just keep going. But we'll find our rectangle is going to be equal to 12 times our 24. And that value is going to be, second. Okay. Well, good thing I have a calculator handy to me. Actually, no, I don't. I don't know where. Oh, I got it. Don't worry about it. So we have a value 12 times 24. That's going to be 288. Okay. But we can't just find out what the entire rectangle is. We're only looking for the shaded areas. So let's go ahead and find our circles. Our circles, since there's two of them, we're going to go ahead and put a 2 here. Okay. And we know that they're congruent to each other because they have the same radius. Okay, that was way back. What? Section, what, 9.2, 9.3, maybe something like that. Okay. Same radius, same circle. Okay. So 2 times, because there's 2 circles, the pi r squared, which we know r is going to be 6. So 6 squared. That, of course, is going to equal 2 times 36 pi. Of course, you don't need to simplify it. Go ahead and just put that into your calculator. And actually, I got to do it a little bit differently. I got to actually solve this out. So times 36 times, oh dear. Okay. Okay. It looks like we're going to get 226.19467 just for round off error's sake. We'll leave it like that. And then finally, our green, just so we did in the last problem, our green, the shaded areas. So kind of just, sure, we'll do that. The shaded areas is equal to those 2 numbers, which I'm going to go ahead and put all that stuff in here already, which is 288, like so. And we have our red here. Circle, which is going to be 226. 67. Plus, no items, subtraction. And this value is going to equal, oh man, gotta make sure that my math here is correct. I could probably do it in my head, but I don't want it. Sounds like a lot of it. I don't currently have, right? So it's going to equal 61.805 feet squared. That's it. That is all 9.9. However, there is one brief thing I want to talk about and kind of want to go over is that whenever we talked about don't talk about this part. Actually, you know what? We'll start from scratch. Actually, we can. Okay. I'm trying to think. Is there a possibility that I can go to a different? Oh, you know what? We'll just start with either this slide or maybe the other one. So let's work on it now. We'll start here. Okay. I want you to make a not necessarily a new section in your notes, but kind of go where you have space. Okay. This is what I want to show you. Okay, everything in purple here is going to be kind of new stuff. Or not new stuff, but a different way to think about it. Okay. If I have a circle here, actually a pretty decent circle. Okay. We know that a diameter is going to split it directly in half. Okay. The diameter, right, diameter is 180 degrees. Well, in the last lesson, we talked about radians, and that the diameter, 180 degrees, is also equal to pi. Okay. So we'll keep that in the back of our mind. But then we're going to compare it to some other values. Let's say if we had this thing, We have a right angle. Well, a right angle is 90 degrees. Well, in my diameter, I said that was 180 degrees, and now I'm half that. So it stands to reason that if I'm half of my angle degree, then I'm also going to be half of my radian. Ooh, look at that. Look at that. Okay. And it keeps following, right? What if I went with a, ooh, that's a bad one. I went with a 45 degree. So this was 45 degrees. Another half of 90 degrees. 5 forward. Okay. What I'm trying to get at is that there's a relationship here. Okay. We already know that there's multiple parts of a circle. Right? We have 180 degrees, that's half of a circle. We have 90 degrees, that's a fourth of a circle. And then we have 45 degrees, which is, I guess, an eighth of a circle. Okay. So I'm going to relate this back to now the previous problems. Look over here. If we know that 35 meters squared is a area of a sector, then we know for sure that the actual area of the circle must be larger than 35 meters squared. The same thing that can be said the other way around. If we were looking at our larger arc, we found 64 pi. Well, 64 pi is 64 times 3.141592, whatever, 6. I think it was. Say 6 is the next letter, or next number after that. Well, 64 times 3 alone is definitely greater than 39.695. Okay. And so the idea I want you to understand here is that this is all fractional. This is all fractional. Okay. Another way to put it is that if I were looking at this, here degrees, 70 degrees here out of 360. If you put that into a calculator, okay, take your calculator out, you get 70 divided by 360. That's going to equal 19.4 repeating percent. Okay. But if I take my area of the sector, the smaller sector, which we said before was 39.695, right? Of course, there's some round off error there, maybe a little bit. Okay. And we take that, not 360. You take that and you put it as your ratio for your whole, right? Your area of the circle here. You get 3 point. Oops, hold on. Let me make sure I'm doing the math correctly. Yep, that should be good. 39.695 divided by 64 times pi. And would you look at that? You get it so close. 19.74%. Okay. Kind of messed up on the spacing there. But the point I'm trying to illustrate to you is that essentially you have a decimal equal to a decimal, or a percentage equal to a percentage, and you'll find that in every single problem here. So here's this one: 265.072 divided by 225. If we do this, 265.072 divided by 225, pi, we get the value of 0.375. Okay, that's our decimal. But if I take 135 and put that over 360, 135 divided by 360, I get the value of 0.375. Okay, we'll talk more about this tomorrow on Friday. Okay, that's because actually that's whenever I'm going to be teaching this lesson, and I'm hoping it's going to make a little bit more sense then, in case you don't understand it in this video. But that's essentially what we're doing. We're comparing fractions, we're comparing decimals, we're comparing percentages, okay? And I bring this to light here, right? I bring this up because we have a problem coming up in our quiz that's going to have a percentage, and it's not necessarily something that we saw in our notes. Okay, so I want to bring it up here. I want to show it here now that you're just comparing a piece of something and the whole piece. Okay, I'm comparing 135 degrees out of 360. I'm comparing 265.072 centimeters squared over 225 pi centimeters squared. Okay, I'm comparing a smaller portion on top and the large whole portion on the bottom. Okay, and so that's what I want to leave you with. But if you have any questions, feel free to ask in class at an appropriate time. But for the time being, go ahead and do your best on all the things, and I will talk to you all later. Bye-bye.